meeting has been completed. And we will also post the PowerPoints so that you may review those as well. So check back on our website if you missed something tonight, and you'll be able to see the recording of this meeting as well as the PowerPoint. As I said, we're just going to allow a couple more minutes for people to join the meeting. I've got people trickling into the waiting room. If you've just joined us, please go ahead and introduce yourself in the chat. We'd love to know who's here with us tonight. And if you have any questions, you can post those in the chat as well. If we will be having a verbal question and answer session at the end of the presentation tonight, but we do like to get those questions in the chat so that if any questions don't get answered during that verbal question and answer session, we've got a record of them and we can try to get you an answer after the meeting. I'm just going to give it one more minute here. I see a few more people coming in the waiting room here. All right, well, I think we're going to go ahead and get started now. Welcome everyone to our third Thursday speaker series from the Water Advocates. Please introduce yourself in the chat if you haven't done so, and please post your questions there. We will have a question and answer session verbally at the end of the presentation, but we do like to collect those questions in the chat so that we can get them answered if they don't happen to get answered during the question and answer session. Again, thank you for being here. And I'm going to do a quick introduction before we get to our speaker tonight. First, a quick land acknowledgement, because that's really important it's very important to us as water advocates that we acknowledge whose land we're on and what that means to us. The Water Advocates' main activism areas are located on the traditional homelands of their southern Tiwa pueblos of Cochiti, Santo Domingo, San Felipe, Santa Ana, Sandia, and Isleta, the original peoples of New Mexico, Pueblo, Navajo, and Apache. Since time immemorial, have deep connections to the land and have made significant contributions to the broader community statewide. We honor the land itself and those who remain stewards of this land throughout the generations, and also acknowledge our committed relationship to Indigenous peoples. We gratefully recognize our history. So I have the privilege tonight of introducing Bruce Thomson, who is a UNM professor of environmental engineering and what we respectfully refer to as a water buffalo, or someone who has been in the water world for many, many years and has deep and broad knowledge of all things water. And Bruce is here tonight to speak to us on unconventional sources of water for New Mexico's future. So I'm going to go ahead and turn it over to Bruce. And if Bruce, if you'd like to give a bit more information or to introduce yourself, I would appreciate that.
Sure. Let me start my screen because it's got some important information. The most important information is my email address. I would be delighted to talk to anybody at any time. And on this screen, you will notice that my name does not have a P. So if you put a P in that email address, you get the wrong Bruce Thomson, the evil Bruce Thomson. So yeah, I've been at UNM for going close to 50 years, and been and the longer I've been in this business, here's the preview, check that out. The longer I've been in the business, the more cynical I get, and so I really am excited to participate in this conversation, and especially excited to be invited by the water advocates Years ago, 15, 20 years ago, I was actually a member of the board of directors of its predecessor organization. And I've certainly been friends with your president, Norm Gom, for a long, long time. Um, and so this is a great organization. It has really blossomed in the last 4 or 5 years. And it's a great organization and has a lot of influence on the water discussions in the state. So again, my objective of this presentation is to consider the question, are there new sources of water that we have not recognized or taken advantage of in the state of New Mexico? And as I stated before, I am just, every year I get a little more cynical and skeptical of some of these proposals. The proposals are often show up in non-technical documents such as letters to the editor, op-ed pieces. There have been 2 or 3 that really push my buttons in some of the water plans and things like that. So I'm going to consider 5 potential unconventional sources: wastewater reuse, stormwater capture and reuse, development of brackish groundwater resources, utilization of produced water from oil and gas, and interbasin transfers from other river basins. There have been a couple of proposals in the last 2 years, I think, that appeared, written by folks in the Albuquerque Journal as op-ed pieces, got a lot of distribution. So there's 2 points on this slide I want you to remember. The first is that the water rights in New Mexico, in principle, are based on consumptive use, where consumptive use is the amount you withdraw minus the amount you return to the environment. It could be a surface water return, or it could be groundwater infiltration. And the one number I want you to remember is that Albuquerque's consumptive use is right at 40,000 acre feet per year. We use these gosh darn units of acre feet. And what's an acre foot? It's 1/3 of a million gallons. So what? But I think keeping this in mind, 40,000 acre feet, gives you some perspective, because when we start talking about hundreds of thousands of acre feet, just remember that Albuquerque's consumptive use is about 40,000 acre feet. We withdraw 100,000 acre feet in a combination of groundwater and surface water. And at the Southside Water Reclamation Plant, what we used to call a sewage treatment plant, we return 60,000 acre feet. So the difference, withdrawal minus return flow, is 40,000 acre feet. So that's a good number. So we need these sources of water, but the challenges of coming up with new water supplies is very difficult, and yet it's critically important, because I think everybody is acknowledged that the climate is warming. The 50-year impacts. This is a study that was just released about a year ago by the New Mexico Bureau of Geology, and there is a reference there. You can find it if you just look Bureau of Geology Leap Ahead report. It's right there. And I noticed that I'm a co-author of a couple of the chapters. So is Phil King, and I think I saw his name on the website, or on the Zoom link. So that's great. It's a very well done study. It won a national award last year. It's relatively easy to understand, and it's got some information in there for everybody. So one of the predictions is that there will be somewhere between 25 and 35% reduction in surface water flows, primarily the Rio Grande, but also the Pecos River, and certainly the San Juan River, the big rivers that flow through New Mexico. So let's just say there's going to be a 30% reduction in surface water flows. This is compounded by the fact that we're going to have a longer and warmer growing season. And in the time that I've lived in Albuquerque, There's been noticeable warming. There's data in this leap ahead analysis. And a longer growing season and warmer growing season means there's going to be increased demand. So we're looking at two things. We're looking at reduction in surface water flows and at the same time, increased demand. Never mind whether there's more people and more industry that needs the water. So we need to figure out what our water future is and whether these unconventional sources will play a role in meeting these water needs. So let's look at these in sequence. The first is wastewater reuse. And we have basically two types of wastewater reuse, non-potable reuse, and either direct or indirect potable reuse. Non-potable reuse is water that's used for irrigation, plant watering, crops, parks, things like that. We don't drink it. Indirect potable reuse and direct potable use, the treated wastewater eventually makes it into our
I think you're muted.
Bruce, the audio seems to have dropped out. I think you might have accidentally hit your mute button.
did. I'm sorry.
Could you go back about 30 seconds? I thought maybe it was my internet, but then I got a notice for that it was everyone's.
I apologize. Let me go back. Oh shoot!
We got to the part about impotable water for being for irrigation. So
okay,
you can start right after that.
I accidentally must have hit the wrong button. So our first discussion is on wastewater reuse. Non-potable is irrigation, parks, landscape things. And then there's two types of potable reuse. One is indirect, where we inject the treated wastewater into an environmental buffer, like a reservoir, or Rio Rancho is injecting it into the aquifer. And at some point in the future, they will take that water out and put it into the drinking water system. El Paso, by the way, has been doing IPR for 30 years. They have the Fred Hervey plant, injects well-treated wastewater into an aquifer. The water flows to extraction wells. It's about a 2-year travel time. And then they recover that and put it into the potable water system. So let's see, 30 years, 2-year travel time. Some of those water molecules have been through the cycle in principle 15 times. So that's a great example of indirect potable reuse. And then direct potable use is where we introduce the water directly into the potable water supply. That's the toilet to tap concept. El Paso's planning on that. The city of Cloudcraft, village of Cloudcraft, has built a system like that, although it's not operating yet. So here's an example of non-potable use two that are operated by the Albuquerque Bernalillo County Water Utility Authority. I'm just going to call them the authority. In the South Valley, they take water from the treated water from the Southside Water Reclamation Plant, pump it up the hill right past my house. I live right about there, if you can see that. And they use it for golf courses and parks and ball fields. In the north side of town, they have the non-potable reclamation project where they take water from the river. They don't treat it other than it's filtered by the sands in the basin of the river, and then they use it to irrigate ball fields and sort of. So the problem with non-potable reuse is that if you're going to do it, you got to have two different separate distribution and storage systems. So you're laying twice the amount of pipe in the streets. You have twice the number of water reservoirs and so forth. And then you worry about accidental cross-contamination. So non-potable reuse is great, but it's got some problems that you need to recognize. And I've noticed that water short communities often have reduced or eliminated their public landscaping, parks and things like that. So that reduces the demand for NPR. So NPR, non-potable use, is less attractive than it used to be. Now, there are the two variations on the direct potable use are where you use the treated wastewater that's sent to some environmental buffer, storage or something like that, or the direct potable use where it goes directly into a distribution system. So that might be where you'd have advanced water, you'd take your treated wastewater or non-potable water, you'd give it some type of advanced treatment, and then after that, you would give it some additional treatment. Here's the engineered buffer. That might be a reservoir or an aquifer. And then the finished water is treated. And so the issues with direct potable use are technical issues. So return flow credits and water rights. Remember, if you're taking that wastewater that's normally returned to the river and reusing it, that has implications on your water rights. There are issues with the Safe Drinking Water Act regulations. These regulations at present do not address the concerns of direct potable reuse. There are some states, California, for example, have specific regulations for direct potable reuse. There are technical issues where you have to deal with the health issues. How do you assure that this water is sufficiently safe that you can introduce it into the distribution system? There are technologies, energy requirements. Then O&M, the operators need to have special training because these are advanced treatment technologies like reverse osmosis that is not part of the usual treatment technologies that water treatment plant operators have. There's cost, and then of course there's the public acceptability of the yuck factor. I am going to mention this a couple times. You probably have figured out by now I'm in a hotel room in Santa Fe, and that's because there are wastewater reuse regulations that are being heard by the Water Quality Control Commission. And I think Brittany's going to give you a link on how you can actually log in and watch this. And if you do watch this, you are a glutton for punishment because they are extremely tedious. But do participate if you can. So I wanted to point out, we think about water reuse as a conservation measure. And if a community gets return flow credits, that's not necessarily true. And so over here, I've got a schematic of the Albuquerque water cycle. We take water from the river and we take water from wells. At present, it's about 2/3 from the river, 1/3 from wells. It depends on what the flow is in the river, but we round numbers, and actually it's pretty accurate. We take 100,000 acre feet, we run it through the community, it goes to the wastewater reclamation plant. We return 60,000 acre feet, and that's how we come up with our consumptive use of 40,000 acre feet. If we recycled half of that water, back to the community. Now we're only dumping 40,000 acre feet. We don't need to take 100,000 acre feet. We're only taking 80,000 acre feet, but our consumptive use is still 40,000 acre feet. So if we're getting return flow credits, it's important to recognize that wastewater reuse may not constitute an actual conservation. And a couple of points I wanted to make was that the Southside Water Reclamation Plant is the third largest tributary to the Rio Grande. So there are important consequences to downstream users. You know, I used to have a bumper sticker that said, "Flush twice, Texas needs the water." It's also an important source of environmental flows to maintain this endangered and threatened species in the water and to keep the riparian bosque green. Now, one city in New Mexico that doesn't get return flow credits is Santa Fe. And so Santa Fe has undertaken several years of studies, and I was part of one of them, to look at opportunities for either reusing the water or simply dumping it back into the Rio Grande. And I had a field tech, and don't anybody tell my daughter that my field tech was wading in the Santa Fe River and helping me with that study. But yeah. So Santa Fe is one of the notable communities that does not get return flow credits, and so they have an opportunity for doing wastewater reuse. Oops. Let's look at our next potential source of unconventional water, and that's stormwater capture and use. And there is a lot of interest in stormwater capture because we see it every time it rains. And it's easy to imagine how we might capture it. All we got to do is dam the stream, divert the water, and we've solved, well, we've we've developed a new water right. And, it's stormwater capture and reuse are frequently proposed at public meetings as a source of water. It was ranked the second highest alternative for augmenting the water supply of the Water Utility Authority in their Water 2120, which is a 100-year water plan. It's a component of EPA's Water Reuse Action Plan, the RAP, and Water Reuse New Mexico also considers stormwater capture. And by the way, the Middle Rio Grande water advocates, mid-region water advocates have permission to post these slides. So you don't need to copy these websites. You'll have access to these slides fairly shortly. So there are some significant challenges for stormwater capture and use. First is water rights. Second is hydrology. Third is the engineering and infrastructure, water quality, economics. And when we talk about stormwater, I want to make a distinction between detention and retention. So detention is where we detain the water for later reuse or release, and retention is where we retain it indefinitely for reuse. And it's sort of a subtle distinction, but it has significant regulatory constraints. And so this water rights thing, even though it looks like that water is just flowing down the ditches, arroyos, off the parking lots, it looks like it's free for the taking. This Constitution says, and I love this phrase, all water of every stream, perennial or torrential. We don't use torrential very often, but the water belongs to the public and is subject to public appropriate, meaning you have to have a water right. You have to have a water right if you're going to capture stormwater and use it once it leaves your site. Now, they've made the exception, the state engineer has made the exception for on-site capture and reuse. And so I've got rain barrels, but once it leaves my property, it belongs to the public and I have to have a water right. The other thing is that there is a state rule, the a regulation that says that you cannot retain it for longer than 96 hours. So that previous slide talked about the distinction between detention and retention. So nearly all of the dams, the stormwater dams in New Mexico, and certainly all of the ones that you see as you drive around Albuquerque, are detention dams. They are designed to release the water in 96 hours. And because they don't have to retain the water indefinitely, they are dry dams. And that has some engineering connotations we'll deal with. So one of the very attractive um, uh, features or aspects, characteristics that the public sees is the North Diversion Channel, which parallels I-25. It starts down by the University of New Mexico and flows north. So the river flows south, but our stormwater flows north. It's sort of an interesting conundrum. But the North Diversion Channel drains almost all of the Northeast Heights and even some of the Southeast Heights. It flows north, has steep, smooth, very fast flows, and every so often, every couple of years, it kills somebody. Requires frequent maintenance. Here's a great picture of the freeway channel flowing nearly full and kicking up a giant rooster tail. We had a issue last summer, you may remember, where the flow was coming down so fast it floated a 40-foot section of concrete that wrapped around one of the big bridge piers, and we thought we were going to take out the San Pedro Bridge. So this is the North Diversion Channel. You can see the North Diversion Channel is this feature in blue. It flows right by the San Juan Chama drinking water plant. So it'd be just a matter of dumping that water, having it flow south. Well, the problem is that North Diversion Channel, the water shows up only during our stormwater events, and those are typically very short duration, 1, 2, 6, maybe 10-hour events. And if you look at the hydrology, this is a plot of the storm events during 2017 and 2000. Oh, this is not just the storm events. This is the storm events during the monsoon. So this is the wettest time of year. And you can see that we have these infrequent high flow events where all of a sudden, a storm comes in and it goes from nothing to thousands of CFS in just a matter of an hour or less. And then equally rapidly, the flows drop. And the average flow during the monsoon season, which is when we need the water. It's our wettest season, and it's when we need the water. The average flow is only 33,000 acre feet. Remember, the one number I wanted you to remember was the consumptive use by the city of Albuquerque is 40,000 acre feet. So yeah, it'd be nice to have this water if we could, but it's not very much. So here's a picture of one of the biggest dams in the Albuquerque area. It's the John Robert Dam. It's the Breaking Bad Dam. And, it's a dry dam. It's got the dinosaur teeth and everything like that, real famous. But we don't store water in there. We don't store water in there. And the reason we don't is because it's got to be released in 96 hours. So it is a dry dam. It is not gated. It doesn't have an impervious core. It doesn't have erosion protection. on the upstream and downstream faces, and it doesn't have a horizontal rocker drainage layer. So if we wanted to use the John Robert Dam for stormwater capture and reuse, we'd have to reconstruct the dam. Oh, also, we'd have to enlarge it so that we would have sufficient volume to provide stormwater protection and a volume for stormwater capture and storage. So, doggone it, that's developed land all the way around that. So if we were going to enlarge it, we would inundate some of the most expensive houses in Albuquerque up there on Bear Canyon Arroyo. So we'd have to reconstruct the dam at a very large cost, and we'd have to acquire additional land to provide additional volume. So stormwater capture and reuse is a challenge. Let's look at the next one that's been proposed. There's been quite a bit of interest in this. The governor mentioned it early last winter, and that was developing our deep brackish groundwater resources. And this interest was largely based on our understanding developed back in the early 60s, and they draw these maps like this, and just gorgeous maps. It looks like, geez, a third of the state is underlain by brackish groundwater. And brackish is defined down here in the lower right-hand corner, has a total dissolved solids concentration of 1,000 to 15,000, maybe a little higher than that, whereas seawater is 35,000. This is parts per million or milligrams per liter. So if you take and evaporate a glass of water to dryness, that white salt that's left in the bottom of your vase or whatever is the total dissolved solids. So this is what it looked like in 1962. The New Mexico Bureau of Geology has got an aquifer mapping program, and it's much more complicated than that two-dimensional map. And furthermore, it's three-dimensional. You've got multiple aquifers in most of these basins, and we don't have any information on the hydraulic properties. And even this map is simplified. Just last year, the USGS published a model of the Rio San Jose Basin, which is west of the Rio Puerco. Here's Grants, New Mexico. Mount Taylor's about there. The Rio Puerco is pretty much the eastern boundary of this. And you can see there's all sorts of complexity, geologic complexity, igneous dikes, volcanic vents, and so forth. So it's not a nice picture like the state engineer's office released in 1962. So some of the challenges are the challenges of the hydrogeology, the fact that most of these deep brackish groundwater resources are not recharged. It is not a sustainable resource, and I'll talk about that in a second. The geochemistry is much more complicated than the seawater. And then this is another one that we don't think about very much, which is how do you dispose of the waste from the desalination process? So let's go through those. Groundwater capture depends on the hydraulic properties of the basin. So I'm comparing two aquifers. One is Ridgecrest number 5. This is a well in the Southeast Heights that provides water supply for much of my neighborhood. And so you can see that the transmissivity of Ridgecrest number 5 is about 5 times what it is out there in the Rio Puerco Basin. And so I did, I know just enough hydrogeology to be dangerous. I looked at the drawdown. I did some calculations. The drawdown of the Ridgecrest well, a few tens of feet at most after 10 years, compared to the drawdown in the Puerco Basin. And we're talking about hundreds of feet of drawdown from a large well. And also the radius of that drawdown extends out many, many hundreds of feet. So the consequences are, where in the city of Albuquerque, we've got big wells, big production wells, and they're 1 or 2 or 5 miles apart. They're distributed all over the municipality. There's 90 wells that the city, big, large municipal wells that the city owns. If we did something like this out on the west of the Rio Puerco, these wells would have to be tens of miles apart so that the cone of depression did not interfere with each other. There was a study, the only study that I know of, and there's been some testimony to this past week, I think, that confirms it. The only study I know of where they actually tried to characterize the deep saline water resources was about a little over 10 years ago out in western Rio Rancho, just over the top of the mesa. And this was a study funded by the state of New Mexico. They drilled 2 wells. One was about 3,000 feet, and that would be their water supply well. Another one that was drilled it was a little over 6,000 feet, and that would be their disposal well. So 2 wells, and they did it was a first class study. They did a pump test on this source water well, and 2 very competent geologists, one at Sandia, one with a very prestigious hydrogeo firm, they used the same amount of data, and they tried to estimate the volume of aquifer, the volume of water that would be available. One estimate was 576,000 acre feet. The other was 2.6 million acre feet. Okay, and these guys, TDS is a third that of seawater, and these guys, in their study, they said, that's somewhere between 77 and 350 years of water supply. Well, I use the same data, and I come up with, so here is the pumping rate, starts out at 5 million gallons per day, increases to 36 million gallons, which was part of their study. Here is the lower estimate, 576,000 acre feet. The red line is the total amount of volume that was pumped, and it shows that this will exceed that lower volume estimate after about 25 years, or will exceed the higher volume estimate, 2.6 million acre feet, after about 50 years. So 60 years, I'm sorry. The challenge is, here we go, let's see if I can get this. The challenge is that was one proposal. Prior to 2010, there were 418 wells that were filed with the Office of the State Engineer, notice of intent to divert water. These are known as 7512-25 wells. And so these are just some of the wells in the vicinity of that one project. So if that one project could in fact provide water for 60 years or something like that, what happens if there were 20 or 30 within a 20-mile radius or something like that? The answer is, it's a lot of water, a lot of demand. The annual demand that was projected by these 418 wells was 1.1 million acre feet per year. I mean, just crazy. The other place where a lot of notice of intent has been filed is in the southeast part, in the Permian Basin. There have been actually 39 wells drilled down there, mainly for water supply for the oil industry. I note that only, to the best of my knowledge, only 8 wells 8 of these deep brackish water wells have been drilled since 2010. The other thing, and I'm not going to dwell on this, everybody says, "Oh, gee, we can desalinate this water. We've been doing it for over 60 years, actually longer than that. We've been using reverse osmosis since the 1960s. But desalinating seawater is a whole lot easier than desalinating brackish groundwater because of all these other minerals, calcium, magnesium, sulfate, bicarbonate, chloride, and so forth. As part of that Sandoval County study, a very competent engineering firm designed, built, and operated a pilot plant out there. And the plant operator was one of my real remarkable students, a very good guy and a really good wrench turner. He if anybody could make this thing operate, it was Jeremy. And at the end of the study, the principal engineer in charge just said this was just a flippin' nightmare. It is really, really tough to desalinate this water because of all these scale forming minerals. And yeah, I mentioned the 72-12-25. This is the legislation that deals with these deep wells. Up until 2009, you could appropriate that water without a water right. All you had to do was file a notice of intent. The criteria was the aquifer had to be deep and it had to be brackish. Yeah, so that was the instigation for all these, what were there, 700 and something applicants that were filed right before that law took effect. So the issue I want, the aquifer must not be this, oh, son of a gun, come back. The aquifer must not be connected to the overlying formation of surface water. So they are not sustainable. And so my question, I go back to this proposed Sandoval County project, is we're talking about a community of 20 to 50,000 people. What happens to that community when that aquifer is depleted? We've allowed this community to develop. It's dependent on a non-sustainable water supply. When that water supply runs out, whether it's 20 years or 70 years, who cares? What does that community do for a water supply when that supply runs out? Okay, so let me go to my next one. How am I doing on time? I want to try and finish up in the next 10 minutes or so. And that is unconventional source. That's water associated with oil and gas. Primarily, we're concerned with the Permian Basin down in southeast New Mexico because that's where all the biggest activity occurs, and that's where most of the water is generated. We need water for fracking. We need, and then wastewater is produced as a byproduct. That's produced water. I want to just comment a little bit about fracking. And I'm going to skip this. I just want to, I want to point out that everybody hates the oil and gas industry, but that's responsible for basically a third of the funds for this public utility for the state of New Mexico. A third of our operating funds for the state of New Mexico is from oil and gas. So we can point our fingers at them and wring our hands, but at the same time, they're incredibly important to the economy of the state. Fracking it is often mistakenly conflated with all aspects of oil and gas production, and that is not true. Fracking is used to use a very large volume of fresh water, but in 2019, there was an act required, the Produced Water Act was passed that required drillers to report the source of volume that they use for fracking. And we are the only state. I've looked, maybe there's somebody that has got a source of data that I don't know about, but we are the only state that requires the drillers to identify the source of fracking, of water used for fracking. The fresh water used for fracking is this black line down here. Produced water, the really salty water that comes up with oil production, is the red line, and you can see the trends. There's almost no water used for fresh water, no fresh water used for fracking. And the reason is because the produce water is cheaper, it's on site, and they get better results. So let's go. The problem with produced water is about half of it is disposed of in saltwater disposal wells. So you'll hear SWD wells. And the problem is that we don't have enough saltwater disposal wells, enough capacity for the oil industry to continue to grow exponentially. And the big problem with that is with all this deep well injection, deep well disposal, there is increasing risk of seismic activity. Currently, saltwater disposal wells, the cost range, I used to quote $1, but there's been testimony submitted that some disposal companies are charging up to $10 a barrel to dispose of well. So this is what residents of Albuquerque pay. It's somewhere around $1.50 per 1,000 gallons. Water delivered to my house. Saltwater disposal companies are charging somewhere between $24 and $240 per 1,000 gallons. It's really expensive to dispose of produce water, and they're going into deep formations. I don't need to cover that. And you can see that most very large volumes of produced water are generated. This is numbers from 2020. Remember, the new Albuquerque consumptive use was 40,000 gallons, 40,000 acre feet. So the industry generated in 2020 4 times the consumptive use. So it does look like a very attractive source of water to augment our potable water supplies, whether it's potable or irrigation, agriculture, or other sources. It doesn't matter. The problem is that it's really, really expensive and really complicated. So the salinity is from 50,000 ppm to I've seen some reports of 350,000. They're telling us now maybe that's too high. Maybe it's around 200,000. So we're talking again from double to 7 times the salinity of seawater. And more than that is it's this complicated chemistry. So it's really, really complicated to treat. And then I've been doing some work at a desalination research facility, and I pulled open one of the electrical panel boxes. This is a sealed box, right? And it's hard to see, but there's corrosion. If you're going to treat produce water, you can't just use type 304 or type 314 stainless steel. It's really corrosive. It is so corrosive, it'll corrode just about anything you can point to, except for maybe platinum or plastic. So the other problem is this waste disposal challenge. And I just did, kind of a nonsense calculation. But if we evaporated this to dryness, we would have every year a salt pile that's a 1/3 mile in diameter and 617 feet high. I mean, it's just the amount of disposed solids is crazy. Now, in reality, we're not going to evaporate it to dryness for a whole bunch of reasons. will continue to use saltwater disposal wells, but that prevents a constraint as well. And I remind you about the hearings. This is a major topic of the hearings that have been going on all week. And I would encourage you to participate if you can. It's been a tedious week, and it looks like there'll probably be another week, probably in 2 or 3 weeks in the future, because it's a very long and process. My last one is unconventional source 5, which is importing water from elsewhere. A couple of years ago, there was a op-ed piece by a prominent member of the community, said, let's take water from the Mississippi. Well, okay, let's look at that. Probably the best source is Lake Sakakawea, which is up in North Dakota. It's they said, let's just pipe it to New Mexico. Well, it ain't a pipeline. This is going to be a canal 30 feet wide by 7 feet deep, or you can make it a little narrower, a little deeper, whatever. It is going to be a freaking huge infrastructure project. And it's going to take a lot of power, about half the amount of electric power as generated by a unit from a nuclear power plant. Okay, so it's a long pipeline, 1,000 miles. It's got to climb 3,200 feet in elevation. Another one appeared January of 2023. Some economists said, let's take water from the mouth of Atchafalaya. This is where the Mississippi dumps into the Gulf Coast. And in principle, nobody has any value for that fresh water after we dump it into the ocean. So we'll just pipe it from the Atchafalaya, and we'll pipe it all the way up and dump it into the Colorado River. So presumably they want to dump it into the San Juan River, because why pipe it all the way, down to the actual confluence? So I'm an engineer. So this is going to be the same length, 1,100 miles, but it's got to cross the Continental Divide. It's got to go up to 7,000 feet in order to cross the Continental Divide. The volume they were talking about was 10 million acre feet per year, 13,400 CFS, 11 million watts, 11 gigawatts, that we're talking about 2 or 3 nuclear power plants just to provide it. And this thing is going to be 250 feet wide by 21 feet long. I mean, you don't pipe this volume of water. It's a canal. So, there are tremendous costs, and I never put cost to this because there's no point. I maintain that the real problem is not the infrastructure problem, not the water availability problem. The real problem is that you're going to cross all these dry states: North Dakota, South Dakota, Wyoming, Colorado, Nebraska, Kansas. So if you take it from the Mississippi River, you're crossing Louisiana, Texas, Oklahoma, New Mexico. These are the driest states on the continent. And so I maintain that the problem is not infrastructure. It's not cost. The problem is there's not sufficient amount of water, because every one of these states is going to want a piece of that. And let's do just sort of a little mental exercise. Which of the states listed in this list has the least amount of political clout in Washington? I submit it's New Mexico. So yeah, water flows uphill to political power. Conclusions. When is wastewater reuse feasible? First, if the community has water rights, or if they can figure out a way that this constitutes conservation. The treatments, we need treatment standards, and that's the purpose of these regulations that are before the commission now. And if public acceptability can be obtained. So Cloudcroft got it, public acceptability, because every summer they had to truck water up the hill because they knew they were without water. And so you don't miss your water till the well runs dry, and when it's dry, you're willing to accept something that maybe a wetter community wouldn't. when is stormwater capture? If the user can acquire water rights, if the impacts on receiving water are manageable. So, for instance, if we've got a closed basin like the Estancia Basin or Tularosa Basin or southeast New Mexico, where there are no perennial streams, maybe you can do it there. If in southern New Mexico, downstream from Elephant Butte Dam is a delivery point for the New Mexico compact. So if we take the water out downstream from the delivery point, we don't impact the water rights required to deliver to Texas. And if there's no environmental flow restrictions, you have to recognize that acquiring funds to pay for enlarging the dams and the inundation pool is going to be very expensive. And then the quality is really crappy. And I use that term advisedly. How about brackish water? You know, I talked about the technical challenges, the complexity and cost of developing wells. These are deep wells. They're going to be far between. So we're going to have long surface pipeline, the complexity of desalination and waste management and disposal. And then again, my opinion is don't rely on brackish groundwater for public water supply. But if you do, you should use this technology that I designed, built, tested. What about produce water? The produce water will be feasible when the cost of treatment is less than the cost of disposal. And there is some indication that we may be approaching that point now. We'll see. But to date, there has been no demonstration of at the pilot scale of the feasibility of testing it. And I will state that I do not think that it is technically feasible. Never mind the cost. I don't think it's technically feasible because of the complexities of scaling and corrosion. And what about interbasin transfers? I just don't see it because in the West, all available water resources are fully allocated. So in my opinion, the only source of new water is that retrieved by conservation. I think these unconventional sources may have a niche application in some special circumstances, but it's not a silver bullet. And then I close by, these are the index flows of the Rio Grande at Ottawa Bridge over the last 80 years. And boy, there's certainly a trend there. So in my opinion, we need to develop policies that enable an equitable distribution of current supplies to meet future needs, recognizing that future supplies will be diminished by the effects of climate change. So it's going to be a very long and difficult conversation, but that's where I think we need to put our efforts. So with that, this is one of my favorite cartoons when I talk about water treatment. And there's a lot of references. My contact information is on the screen. Please do contact me. I'm going to turn it now back to Brittany.
Wow, that was a fabulous presentation, Bruce. I learned so much and there was so much detail in those slides. So I just want to remind everyone that we will be posting those slides to our website because I know people are going to want to go look at all of those links and look at those numbers more closely. Just an incredible amount of detail and fascinating presentation. I really appreciate it. I want to open it up to question and answers now. Please go ahead and raise your hand and I will call on people. There's the little raise hand button at the bottom of your Zoom screen. So if you have a question for Mr. Thomson, please raise your hand. Okay, I see Ralph Rons has his hand raised. Would you please unmute yourself and ask your question?
Professor Thomson, may I call you Bill? Bruce, may I call you Bruce?
Yeah, I've been called all day yesterday or day before I was called Madam Chair. I like that.
Oh, jeez. I won't do that. Yeah, I'm one of those. Thank you that are saying, deep gratitude for this really great presentation that was, so informative. Um, but I ask maybe a slightly cynical question, and that is when you said that only about 8% of of the water used for fracking is from fresh water. Then I may have misunderstood you, but I thought I heard you say the rest of it's coming from produced water. That's not what I've heard thus far. And if it is, it just seems it would have to be cleaned up very, very well each time it was reused, or it just would turn into sludge very quickly.
Yes, thank you. The there is a link on my slides to the OCD website that has those numbers, the sources of water used for fracking. And
The Oil Conservation Division, right?
Yes, I'm sorry. Thank you. OCD is Oil Conservation Division, which regulates drilling and production of oil. So there is a link to that, and you can confirm those numbers there. You are absolutely right. Before the industry can use produced water, they have for fracking, they don't need to desalinate it. In fact, high salinity water actually improves the oil recovery, and there's some geochemical reasons. But they do have to treat it, but the treatment primarily consists of removing um, particulates because they don't want to plug the formation with the gunk that comes up with production of oil and gas. So they remove the particulates. They also try to remove any free product, floating product, any product that is associated with the oil and gas recovery.
I would think it'd be oil residue. I think that the particulate would be the sand that was pumped down in the first place.
The sand pretty much goes into the formation and stays, but there are some solids that come up.
Okay.
They also add, when they do the fracking, there's a list of chemicals that they add, and that's available. And again, the industry is required to report that to an organization called Frac Focus, FRAC FOCUS. So they're required to report the chemicals that they use. And they adjust the pH, they add corrosion inhibitors, they add biocides to prevent microbial corrosion. They add anti-scalants and things like that. One of the biggest challenge to use of produced water was they add friction reducers. And the traditional friction reducers were not compatible with high salinity water. In the last 10 years, they've developed friction reducers that are compatible with high salinity water. So yes, Frac Focus.
Thank you.
Thanks, Ralph. Does anyone else have any questions? I don't see any other hands raised.
I put everybody to sleep. I do that every time I teach.
No, I think people are just amazed at the amount of data and taking it all in. I know that I am.
Right.
Just so much in your report to get my brain around. It's hard to pick one good question. There's lots of good comments in the in the chat, but I don't see any particular questions. A lot of it is about what's included in the fracking water, and you mentioned that Frac Focus is a good place to look at those. Sig, did you just raise your hand? Would you please go ahead and unmute yourself and ask your question?
No, I had a comment to make. Can you hear me?
Yes.
Yeah, I think liability is a big issue for oil field water. And a few years ago, the producers wanted the state to provide them immunity against liability, and that's a violation of the anti-donation clause. So I think that's a big issue. Whether or not it's actually a problem when cleaned up is another question. But people will think it's a problem, and it will be a problem for that reason. So I think it should be used for fracking.
Oh, absolutely. I agree. I think the industry agrees too. That the industry, but the problem is that the industry produces something on the order of 200,000 acre feet of produce water, and they use something on the order of 40,000 acre feet for fracking. So,
Yes, you were
you
clear
know,
about that in your presentation.
yeah. So there's a large volume that they can't reuse for fracking. They use about half of that for secondary recovery of oil. The water floods. Sometimes it's called enhanced oil recovery. EOR or SRO are the two. So, and so they can get rid of roughly half of their surplus water with EOR or SOR, secondary recovery of oil, but they still have a large volume of water they've got to get rid of. With respect to liability, I am not aware of anybody in the industry that has expressed liability issues as a constraint to how they manage their water at present. Now, if they were to treat it and for reuse, I'm sure there would be some liability issues there. But at present, they're not reusing. In fact, the Produce Water Act of 2019, I think it was, prohibits the reuse of produce water outside of the industry. So there's no outside use of produce water except reuse within the industry. Now, I think Ralph, the previous questioner asked about Frac Focus. The website or the organization is Frac Focus, FRAC Focus, one word, no K in frac, FRAC Focus, FOCUS. I think it's .org. But
Thank
I
you.
just posted it in the chat for y'all.
Thank you. Perfect. A lot
Ella,
of information.
Ella Joan, you want to ask your question?
Thank you for all your time and years, 50 years. Wow.
I started when I was 12.
Yes, 12. That's noted, sir. Yes. I was excited, 5 different ways of water. You went through them. None of them are working. Is there any hope in this presentation at all?
Well, as I preface my remarks by saying I'm a cynic. There are other people that have other very smart people. I think that some of them have niche applications. So, for instance, in the lower Rio Grande, Hatch, Mesilla Valley, I think there's an opportunity to reuse stormwater there. And in fact, I have worked with Phil King and fellows with the Office of the State Engineer to develop a concept for a study that would look at that, because there are some places down there where there's some pretty large dams that they could modify to use and capture stormwater and then dump it into the irrigation ditches. So I think that, but that's a niche. That's a niche. There's not very much water, and it comes in, these, monsoonal deluges. I think there's an opportunity for using deep brackish water in some communities. So, for example, the town of Alamogordo is using brackish water. They have built a facility to use brackish water. It hasn't been operated in a number of years because it's too freaking expensive to operate. But Alamogordo is, in the Tularosa Basin, and they've got a supply that actually is replenished. So that's another example. Down the Salt Basin, I think there's some opportunities to use brackish water. So stormwater capture, wastewater reuse. We've talked about the city of Santa Fe has discussed discussed that. There are a number of small communities, approximately 100 of them, that use wastewater for non-potable uses. They use it
Yes.
for
Yes.
irrigation or landscape. And so, yeah, but these are all niche applications. It's not going to solve the state water problems.
Doggone it. Thank you, though. Come on. We're still fighting. We're still fighting.
Thank you. We did have a question in the chat about gray water versus wastewater. And, is that an option for especially rural communities?
Yes. Gray water has a lot of application. And that falls in that non-potable reuse category, because gray water, certainly you wouldn't want to drink it. And it, where its real application is for folks on septic tanks. If they can recover, replumb their house to capture the gray water. Everybody familiar, gray water is water from showers, from laundry. It's unclear whether it's water from the sink, because some people characterize water from the sink as you're washing things and whatever. But anyhow, it's certainly showers and laundry. So gray water does not come in direct contact with human waste. And it's got great applications on for private wastewater systems. You can separate the gray water from the black water, which this black water goes to your septic tank. The gray water can go to your yard. On a community scale, that's a problem, because then you'd have to have two collection systems. You'd have to have a sewer system for the black water, and you'd have to have a sewer system for the gray water. So the cost of the collection just doubles. So it's great for a household application. I'm not aware of any gray water systems that have worked on a community scale.
Thank you. We have another question about how somebody has heard a lot about how leaky our water pipes are as communities and how old our infrastructure is, and how much water we could be saving just by repairing that infrastructure and not losing that water to leaks and losses.
That's a great question. The large communities, the Albuquerque, Santa Fe, Las Cruces, Roswell, they have very aggressive systems. It's called leak detection systems, but there's industry words for it. It's either non-revenue water because it doesn't flow through a meter, and so we don't measure it, and it doesn't generate revenue for the utility. Sometimes it's called unaccounted for water because, again, it's not metered. But the big communities have aggressive leak detection systems and correction systems. The smaller communities, it's more problematic because they don't have the technical resources. They don't have staff that are able to do these leak detection systems. It's fairly technical. And then they don't have the resources to repair the leaky water lines. So I mentioned Cloudcroft. Cloudcroft's out of water. And one of the issues there is they have a very leaky distribution system. And so, it's been suggested to the community that rather than spend all this money for a wastewater reuse system, perhaps they would get more bang for their buck if they just fix the leaks. So yeah, the big communities have got aggressive leak detection systems. The small communities face some real serious technical and economic challenges.
I think we have time for one more question. And it looks like there's another one in the chat. Will the high cost of water, oh, it just dropped down. The moment I was reading, someone bumped it up. Will the high cost of water disposal affect the prospects for geothermal development in New Mexico?
I'm a skeptic. Geothermal, I grew up in Northern California, and there was a geothermal plant, is a geothermal plant, but it's a little tiny plant. This was in a community, a valley called the Geysers. So it was right there with a lot of hot rock, but it was a tiny plant, and I don't know, 30 megawatts or something like that, enough to power a small community. But go to geothermal, my understanding is the concepts that would be used for geothermal would recycle the water. They'd pump water down into the heat source. It would heat would come back to the surface and it would be recycled. So the consumptive water use would be pretty small. But I'm not a geothermal expert, and I'm a skeptic.
We do have one more question that really wants to be asked, so let's go ahead and make time for that. Someone wants you to discuss in more detail. You had a slide that had a case 1 versus case 2 in wastewater reuse when considering depletions of river flows.
Yes. So the argument I was trying to make was that simply reusing wastewater does not conserve water, because in New Mexico, rather, our water law, the water right, is based on the consumptive use. And so the 2 slides showed that even though we reused half of the water, we took half of the water from the the water reclamation plant, and reused it, we only had to withdraw less water from the river because we were reusing this wastewater. So therefore, the consumptive use didn't change. Now, in Los Angeles, where they don't get return flow credits, if they reuse their wastewater, boy, that's a win for them. They can treat it. It's a whole lot cheaper to treat wastewater for potable reuse, like San Diego is about to do, than it is to desalinate seawater. So, but they don't have those return flow credits. If you have the return flow credits, wastewater reuse doesn't conserve water. It doesn't decrease your consumptive use.
Thank you. So I wanted to go, thank you for answering all of those questions. That was very helpful. I again wanted to let people know that we will be posting the recording of this presentation as well as the PowerPoint slides on our website, nmwateradvocates.org. I'll drop that in the chat. And so please check back. I hope to get those up this weekend. And if not, it'll be early next week. So you can definitely look into more detail and check all of those wonderful links that were in the presentation themselves. And I would like to go on and make a quick request and a call to action, if you will. Give me one moment because I'm not very good at multitasking.
While you're doing that, Brittany, I would like to thank you so much for inviting me. I've enjoyed putting this presentation together, and I've enjoyed working with you and Norm, and there's so many good friends. I'm looking at the list of participants. There's so many good friends out there, and I want to say hello to all of you, and contact me and we'll go have a beer or something.
Thank you so much, Bruce. We feel so honored that you are willing to be here tonight. And I just wanted to also especially thank you. Bruce has been in the NMED's proposed water reuse, water quality control commission hearing all week. And these are all day long hearings, and he's been there. And so the fact that he was willing to be here tonight after spending all week at the hearing just shows his incredible dedication to this important cause, which is, protecting New Mexico's water future. So thank you, Bruce, for taking the time to be with us tonight. And on that note, I would really love it if everyone could try very hard to comment on these reuse rules at the Water Quality Control Commission hearing. There's 1 day left of the hearing, which is tomorrow. They hear comments at 9 a.m. and at 1 p.m. And comments are limited to 3 minutes, so don't feel like you need to prepare something drastic. And I am going to drop into the chat the location where you can sign up. And then I'm also going to show that on the screen because you need to do 2 steps. So let me pull up that other screen. Again, I apologize, multitasking. Okay, so the document is now, or the website is now on the chat, and I'm going to share my screen. So this is, let's see, can you see my screen now? This is where you can sign up to make a comment during the hearing tomorrow, again at 9 o'clock or 1 o'clock, so choose one of those times. But you also, after you fill out this form saying your email, your telephone number, and then what you want to what time. So these are the only 2 times left, right? 9 o'clock and 1 o'clock tomorrow. And then you pick what comments you're trying to make or you're wanting to talk about. But then after you've submitted that form, you really need to email Pamela Jones and let her know that you want to be making a comment tomorrow and tell her which time period you want to make the comments at. And I have heard that the 1 o'clock period tomorrow is very sparsely populated as of right now. So that's a really good time for you to choose if you're able to do so. And again, it's 3 minutes and it's not very long. And then I'm going to show you another, oops, not that one. This document here, I'm going to drop this in the chat also. These are talking points. So you can read through this tonight and pick one of these or 2 of these that speak to your heart about what's important to you with regard to these rules. And you can speak on that during your comment to the commissioners who are hearing this hearing tomorrow. So let me pop this into the chat so that you can copy that link to this document also. And okay, yeah, so the first link that I sent was the form to fill out, and then you're going to fill that form out, but don't forget to also email Pamela Jones. You need to email Pamela to ensure that you get a time slot to make your comments. And then the second document is these talking points. I do want to clarify that the water advocates did not come up with these talking points. New Mexico Climate Justice is the author of these talking points, and we are very grateful that they allowed us to use these tonight. But again, I know that water is precious to everyone who's here. You all have been so amazingly dedicated in coming to each and every one of our speaker series. I see the same names time and time again, and I see these wonderful comments from everyone, and we are so grateful to have you here. And we're really grateful to our sponsors as well. And again, give me 1 second to multitask. So our sponsors are Amigos Bravos, the League of Women Voters, 350 New Mexico, Interfaith Power and Light, and New Mexico Wild. We couldn't do it without them. We really appreciate them getting the word out about these presentations. We don't quite have the information for you on next month, but please stay tuned for your email. As you know, we mention our speaker series in our monthly newsletter that goes out. It's also on all of our socials. If you haven't followed us on Facebook or Instagram or X, formerly known as Twitter, please do. We post interesting things there all the time, and especially post about our speaker series. And if you're interested in donating to help us continue providing all of this educational information, we obviously wouldn't say no. And we would very much appreciate any donation. And if you don't want to donate, but you want to donate money, but you want to donate some of your time, we're always looking for volunteers to help us coordinate all of the wonderful things that we do all month long. So reach out to me if you want to volunteer, and I just put the donate link in the chat as well. Again, thank you everybody so much for participating tonight. And I can't say enough about how amazingly dedicated all of you are. And thank you, Bruce, for dedicating your time tonight, especially after being in the hearings.
Thank you so much.